Right now, charged particles are flowing through your television set. That's electricity. But sometimes the charged particles don't flow. They build up and they build up and they build up and they make big sparks. Whew. That's static electricity.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by socks. Socks stick together.
Lightning bolts and sparks happen when electricity makes air glow. Now, electricity is the flow of tiny particles called electrons. And you know about electrons because they're flowing through your television set right now. But this is static electricity. And static's from a word that means stay. So the charged electrons are staying on that big ball, and they build up a big charge. And then the charge lets go. The electron starts flowing. Isn't that wild? It's lightning. You've probably felt a static electrical charge if you've ever shuffled your feet across the carpet and touched a doorknob or somebody else. Well, here's what happens. As you rub your feet on the carpet, electrons, the tiny pieces of atoms that have electrical charge, build up on you or the carpet so that there's a static charge. Now, by rubbing this fur on this red plastic rod, I end up with electrons on the rod. It has a static electrical charge. So watch what happens when I bring it near this silver-painted ping pong ball. Look, they attract. See? They're pulled together because they have opposite charges. Now there's an old saying, opposites attract. And it may be true for people.
Oh, Bill.
Oh gosh. But it's certainly true for electrical charges. Now suppose we want to make a big static electrical charge. Well, we could use something like this. This is called a Van de Graaff generator. It's named after Robert Van de Graaff. So here's what happens. Electrical charges are deposited on this rubber belt. The rubber belt turns and redeposits the electrical charges up here on this metal ball. Now, since this next part of the demonstration rocks, I'm going to put on my rocker wig of science. Yeah! Now, start the rubber belt turning. Electrical charges are being deposited on the metal ball. They're running through my arm and being deposited in me. And look, it's building up in my rocker wig of science. See, since these charges are all the same, they're not attracting. No, they're repelling. They're pushing apart. So they're pushing the hairs of my rocker wig apart. Now, if I could find a way to get these electrical charges off of me back into some other parts of the room, the hairs wouldn't repel each other. There wouldn't be a static electrical charge. No, the charge would jump. Let's try it. Watch what happens when I bring this ball near this ball. See the spark? The charges jumped. The static electrical charges aren't static. No, they jumped. Static electricity. It rocks. See that? It sparked. Hey, Elaine, how's it going?
Oh, hi, Bill. It's going good. Who am I fooling? It's no use pretending anymore. Every time I do my laundry, I get this embarrassing electron buildup.
Oh, you mean static cling?
Oh, fine. Here I am with my clothes full of electrons, creating a negative static electric charge, and all you can say is static cling.
Well, have you tried spraying it with water?
Huh?
The water absorbs the electric charge. Look. See? Doesn't stick.
But now it's all wet.
Well, what can I tell you, Lane? I mean, it's a process. I mean, you know, it doesn't happen all at once. I mean, first the laundry's in the dryer, spinning around in that desiccated atmosphere. You know, there's no humidity and there's very little water in there. So the electrons, with the friction of the spinning, they can build up on one surface or the other, either on the shirt or the sock. So the electrons, there they are.
Boy, this guy can really go on and on when it comes to static cling. He just goes on and on, and my sock's all wet.
So the sock doesn't stick. I mean, laundry doesn't happen all at once, you know. Sorry.
Here are 3 fun things you can do with a balloon and your hair. 1. Rub a balloon into your hair. Stick it to a wall. 2. Get some sugar. Now, rub the balloon in your hair. It makes a sugar storm. 3. Cut little people out of paper. Rub a balloon into your hair. The people dance. Static, static, static.
Science! Static electricity! Static!
So get this, everything has electrons, and electrons are tiny little charged particles that are part of atoms.
Static on radios and televisions is caused by static electricity on dust and water vapor in the Earth's atmosphere, which the antennas pick up. And now, some more static.
Now for something really shocking!
Here's the static electricity generator, just full to the brim with electrons. I'm going to let some of the electrons jump off. We scientists like to say, I'm letting the electrons discharge. Now, where do they go when we discharge them?
Home? Maybe? I don't know.
Well, they go into the ground.
Oh,
Now, when you say the ground, you mean the ground? Like the Earth? Like part of our planet?
that's what I was thinking.
Yeah, the ground. Well, how do they get there? With a ground wire.
What?
The ground wire runs from the machine right to the main cold water pipe in the lab. And the cold water pipe runs right through the floor. The pipes run underneath the floor of the lab, all the way down here, and then into the Earth. That way electrons can find their way to or from the ground, just like that. You may have seen a third prong on some electrical plugs. Well, that's the ground wire. It lets extra electrons get to or from the ground quickly and quietly. Well, thanks for joining us on Consider the Following. Discharge electrons.
Oh, Bill.
Discharge to the ground.
Bill.
Did you know that?
Lightning can strike backwards from the ground to a cloud. 50 to 100 lightning bolts hit the ground every second all over the Earth.
Now you know!
It won't make a mess on your pants or your dress. Roll over, sit over, do tricks. But they'll stick to a wall in a room or a hall. Balloony sticks, balloony sticks. Just fill them with air, start rubbing your hair with the wackiest toy that you know. Then tell all your friends to buy 9 or 10 from Statico. Balloony sticks.
Balloony Sticks, the balloon toy that sticks to walls. From Statico.
Tales from the Lab with your host, Bill Nye.
Here it is. Once upon a time, Many, many years ago in Greece, there lived some pine trees. And although the pine trees eventually died, some of their sap hardened into a gold-colored substance we call amber. Many years later, amber played an important part in a movie about dinosaurs that made lots and lots of money. Anyway, many, many years before that, a Greek philosopher named Thales took some amber of his own and polished it with a cloth. He noticed that after polishing, the amber would attract small objects like dust and hair. We know today that Thales was rubbing electrons from the cloth onto the amber, making the amber negatively charged. The Greek word for amber is electron, which is where we get the word electricity. The end. Electric motors, like the ones in blenders, can make electrical noise that looks and sounds just like static. Electric motors also can help you make a mighty mean banana milkshake.
Third down and 4 now. Ball is snapped. Hand off to Electronsky.
Oh, not again, Bill. I'm trying to watch the game. Turn off the blender.
Field rapidly now. And he's driven out about the 40-yard line.
Are you feeling dull, boring, negative? Like everything is the same old, same old? Well, worry no more and let Johnny Static give a charge to your life. Not to mention your hairdo. Johnny's unique style of hair design has helped to add a spark to millions of people like yourself. So act now to add a jolt to your hair tomorrow.
Hey, we're on top of the Space Needle in Seattle, Washington. About 184 meters off the ground. Now, this is the closest thing to a cloud. So, we've got lightning rods on it. There's 24 lightning rods, about this tall, and there's one big one. So if an electrical storm comes along, the electrical charges are going to find their way to the ground through one of these things. Pretty cool, huh?
Careful.
Here are 2 fun things you can do with your hair and a comb.
1. Cut a square paper. Tape it in a roll, like this. Then, comb your hair very fast. Hold the comb near the paper. Wow! Neato!
2. Comb your hair again. Now hold the comb near running water. The water bends.
Electrons went from your hair to the comb. All those extra electrons are what pulled the paper.
The comb built up a negative charge. That's what pulled the water molecules.
Static!
Hey, you, get yourselves a pencil.
'Cause you're gonna need it later.
Static charges build up on things when they rub together, right? Well, try this. Get a plastic soft drink bottle and a glass one. Rub the plastic one with a wool sweater. Set it down on edge like that. Now rub the glass one with a piece of silk you might have lying around the house. What happens when you bring them near each other? Try it. I said try it!
When you build up these tiny little charged particles, you get static electricity.
Uh-huh.
Did you know that?
The safest place to be during a thunderstorm is in your car. A flash of lightning may be up to 140 kilometers long.
Now you know! You can make your own precision static electricity detector called an electroscope. Yeah, all you need is a peanut butter jar. Of course, it's got to be empty, like this one.
Mm-hmm.
Then you need a coat hanger. And you may want to get an adult to help you with this part, but cut the coat hanger in 2 places like this.
Watch yourself there.
And now we want this piece of coat hanger to go through a hole in a peanut butter jar lid. Now, a great way to do this is with a pair of pliers and a candle. You definitely want an adult to help you with this part. After it's warm, push the coat hanger through the peanut butter jar lid. Oh, look at that. Oh, look at that. Now that right there, that is a great hole in a peanut butter jar lid for a coat hanger right there. That is a great coat hanger. Now, piece of aluminum foil. Cut it with scissors. Use your fingernail and smooth it out. Fold the piece of aluminum foil over the hook part of the coat hanger. Now screw the jar back together. Secure the coat hanger with a little piece of clay.
How long is this going to go on, Bill?
And we need an electrode ball. You can use a piece of aluminum foil. Roll it into a ball and stick it on top of the coat hanger. Now you need some static electricity.
You're good at that. You're a little too good at that, Bill.
Look, the leaves of aluminum foil push apart. The leaves of foil are moving and I'm not even touching it.
So?
I think it's pretty cool. It is cool. It's an electroscope right here in a peanut butter jar.
What can you do with a jelly jar?
This is how lightning works. Electrical charges build up and they push away from each other. Eventually they push away from each other so much they end up falling to the ground. With this I could, dare I say it, rule the world. Well, maybe not, but it's pretty cool.
Now for something really shocking!
When lightning strikes, it heats the air to over 30,000 degrees Celsius. Hot air smacks into cool air, and that makes thunder. Lightning and thunder, they come from static electricity. Jumping electrons.
I think they're in for a surprise. I send electric arcs directly into wet paint on glass. Don't try this at home, and it spreads the paint and moves through it and does things that I wouldn't get any other way. This is weird science, if you will. I'm using weird science to make art objects. I'm actually sending miniature lightning bolts into wet paint on glass. And the electrons come streaming out of the lightning brush, trying to get to ground. Mysterious, strange, this is cool science. Out of that rod comes 1.5 million volts of lightning. It jumps through the air, hits the wet paint on the glass, and gives me elegant surprises. New things that I would not find any other way.
Static electricity isn't always static. That is, it doesn't always stay in one place. Sometimes, when it builds up enough, it can jump from one thing to another.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love
for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love.
Well, that's our show. Thanks for watching. If you'll excuse me, I got about 1,000,000 volts of electricity to keep track of. Keep your electrons jumping.
Produced in association with the National Science Foundation.
Lightning!
There you go. Keep going. Use that facial expression. And without.
So we ready to do it?
Here's what I like to say. Static charges build up when things rub on each other. That's what I like to say. Static charges build up. No problem. Here we go. Static charges build up when things rub on each other, right? Well, get a punch this, man.
Whoa. Keep going there. Use that facial expression.
What do you think, Coulomb? Rub the plastic one. So let me do it again. Static charges build up when things rub on each other, right? Get a plastic soft drink bottle and a glass one. Rub the plastic one with a wool sweater. Then rub the glass one with a piece of silk you might have lying around the house. What happens when you bring the bottles near each other? I said try it!